x comma 1, x comma 2. Then take second element y comma 1 and y comma 2. This is called the ordered pair from A to B. The first element is B and first element is R. So therefore, these two are not equal. P cross Q is not equal to Q cross P. So x belongs to A and y belongs to B. This is called the Cartesian product. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding the very important and the easiest chapter, that is second chapter, relations and function. Now before going to exact the chapter, let me discuss regarding the weightage in this chapter. So in this chapter you are going to get one 1 mark question and one 2 mark question and one 3 mark question and one 5 mark. All pattern of questions you are going to get. 1 mark question 1, 2 mark, 3 marks and 5 marks questions. Totally the weightage for this is 11 marks. So you are going to get 11 marks. Now let us come to the exact chapter. Now let us know, you might have been studied in your previous classes regarding the ordered pair. So let me discuss regarding an ordered pair. So what is meant by an ordered pair? Ordered pair is nothing but, let us consider two sets. If P and Q are any two sets, then the pair of elements written in the small brackets and grouped together in a particular order like this, P comma Q, where P belongs to P and Q belongs to Q, is called an ordered pair. Now let us consider, for example, x comma y. This is an ordered pair. P comma Q, this is called an ordered pair. A comma B, this is called an ordered pair. 1 comma 2, they are called as the ordered pair. Here, for any two sets, first member is an element of set A and second member is an element of set B. So similarly, P and Q means here P is an element of the set P and Q is an element of the set capital Q. That means for any two sets P and Q, where the ordered pair is denoted as P comma Q. Here P is an element of the set capital P and Q is an element of the set capital Q. That means first member is an element of a set A and the second member is an element of a set B. So this A comma B, P comma Q, 1 comma 2, x comma y in particular will represents an ordered pair. That is any pair of the form P comma Q, where P belongs to capital P and Q belongs to capital Q, the second set, then P comma Q is called an ordered pair. A comma B, x comma y, they are called as an ordered pair. Okay. Now, once if you know the ordered pair, now we are going to define the Cartesian product. Cartesian product of two sets. So, the Cartesian product two sets A and B is denoted as A cross B. A cross B is called the Cartesian product A cross B. Here A cross B is nothing but set of all ordered pairs such that x belongs to A and y belongs to B. That means here first member is an element of A and second member is an element of B. So x belongs to A and y belongs to B. This is called the Cartesian product. So the Cartesian product of two sets A and B is denoted as A cross B. Here A cross B is equal to x comma y such that x belongs to A and y belongs to B. Now let us come to the definition. What is the definition? The definition of Cartesian product. So given two non-empty sets P and Q, the Cartesian product of P and Q is denoted as P cross Q is a set of all ordered pair of elements from P and Q, that is denoted as P cross Q is equal to P comma Q such that P belongs to capital P and Q belongs to capital Q. That means first member is an element here. The first member is an element of P and second member is an element of Q. First member is an element of first set and second member is an element of second set. In general, the Cartesian product of two sets A, P and Q is P cross Q is equal to P comma Q such that P belongs to capital P and Q belongs to capital Q. Now let us come to an example. Let us consider, let A is equal to X comma Y and B is equal to, let us consider the two elements 1 comma 2. The Cartesian product of A and B is denoted as A cross B is equal to, now write down the ordered pair X comma 1, X comma 2. Similarly, take Y comma 1 and Y comma 2. This is called the ordered pair. So, X comma 1, X comma 2. Then take second element Y comma 1 and Y comma 2. This is called the ordered pair from A to B. Now, suppose if you want to write B cross A, B into A, B cross A is equal to, here the first member, the set of all first members are from B, 1 comma X, then 1 comma Y. Similarly, 2 comma X and 2 comma Y. So, these are the elements of A cross B and B cross C. So, they are called as the Cartesian product. So, the Cartesian product of these two sets A and B is A cross B or B cross C. Okay. Now, this is very important concept. Okay, let us come to the next problem. What is the problem given? If x plus 1 comma y minus 2 is equal to 3 comma 1, find the values of x and y. So, what is given here? By equality we can write, since these two are equal, by equality of this ordered pairs, x plus 1 is equal to 3 and y minus 2 is equal to 1. So, first element x plus 1 is equal to 3, y minus 2 is equal to 1. So, here x is equal to transfer plus 1 to right hand side, you will get minus 1, x is equal to 3 minus 1 is 2. Here transfer minus 2 to right hand side, this becomes plus 2, y is equal to 3. So, therefore, x comma y is equal to 2 comma 3. Very simple, one more question, you will get one more questions like this. So, what is given? X plus 1 is equal to 3, therefore, x is equal to 3 minus 1 is 2, y minus 2 is equal to 1. If you transfer minus 1, minus 2 becomes plus 1, y is equal to 1 plus 2, that is 3, y is equal to 3. Let us come to a similar problem. If x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, find the values of x and y. Similar type problem. By equality, these two are equal and these two are equal. So, x by 3 plus 1 is equal to 5 by 3 and y minus 2 by 3 is equal to 1 by 3. So, if you want, you can take LCM and simplify. Otherwise, you can transfer this. X by 3 is equal to 5 by 3 and plus 1 becomes minus 1. X by 3 is equal to, take LCM, 3 is the LCM, 5 minus 3 ones are 3, that is 5 minus 3 is 2 by 3. So, 3 gets cancelled, you will get x is equal to 2. That's it, very simple. Here, y is equal to 1 by 3, transfer minus 2 by 3 becomes plus 2 by 3. So, you can take LCM, 3 is the LCM, 3 gets cancelled, 1 plus 2, that is 3 by 3. So, 3 by 3 is nothing but 1. So, y is equal to 1. So, the values of x and y are x comma y is equal to 2 comma 1 is the required answer. That's it. Okay. See here, x by 3 plus 1 is equal to 5 by 3. Y minus 2 by 3 is equal to 1 by 3. Transfer plus 1, this becomes minus 1. Take LCM, 3 is the LCM. 5 minus 3 ones are 3. 5 minus 3 is 2 by 3. Cancel, divide by 3. 3 and 3 gets cancelled. X is equal to 2. Here, y minus 2 by 3 is equal to 1 by 3. Y is equal to 1 by 3. Transfer this minus 2 by 3 becomes plus 2 by 3. So, 3 is the LCM. 1 plus 2. 3 by 3 is 1. So, y is equal to 1. Therefore, the required values of x and y are x comma y is equal to 2 comma 1. Hope you followed this. Now, let us come to the next problem. If P is equal to A, B, C and Q is equal to R, form the set P cross Q and Q cross P. Also, are these two products equal? Verify whether these two products are equal or not. Just find out P cross Q and Q cross P. Verify whether they are equal or not. Now, write on the first one. Now write P into Q. What is P? P is equal to A, B, C, Q is equal to R. So I will take first element as A comma R, then B comma R, then C comma R. This is P cross Q. So first element is A comma R, B comma R and C comma R. Now let us come to Q cross P. Now Q cross P from this and this, R comma A, then R comma B and R comma C. R comma A, R comma B and R comma C. See, observe carefully. Here first element is A, here first element is R, here first element is B and first element is R. So therefore these two are not equal. P cross Q is not equal to Q cross P. They are not commutative. Now let us come to the next problem. What is the problem given? If G is equal to 7, 8, H is equal to 5, 4, 2, find G cross H and H cross G. Now let us find out the first one. First one is G cross H. Now G contains 7, 1, H contains 5, 4, 2. Write down 7, 5, 7, 4, then 7, 2. Similarly, take next element 8, 5, then 8, 4 and 8, 2. These are the elements of G cross H. Now second one is H cross G. H and G. From this, the first elements are 5, 7, then 5, 8. Next 4, 7, then 4, 8. Then 2, 7, and 2, 8. These are the elements of the sets G cross H and H cross G. The Cartesian product of G and H and G is this. So here also they are not equal. G cross H is not equal to H cross G. So here G cross H is 7, 5, 7, 4, 7, 2. 8, 5, 8, 4, 8, 2. Similarly, H cross G is nothing but 5, 7, 5, 8, 4, 7, 4, 8, 2, 7 and 2, 8. These are the Cartesian product of these two sets. Hope you followed. So, in Cartesian product, first member is an element of set A and second member is an element of set B here. First member is an element of set G and second member is an element of H, 7, 5. Similarly, in H cross G, first member is an element of H and second member is an element of G. Okay. Now, let us come to this example. This is very important. It's a 3-marker question. Now, let A is equal to 1, 2, 3, B is equal to 3, 4, C is equal to 4, 5, 6. Find first one, A cross B intersection C and second one is A cross B intersection A cross C. Now, first find out here B intersection C. Intersection means the common elements in B and C. So, here we don't have 3 and the common element is 4. 4 is the common element. Now, find out A cross B intersection C. A cross B intersection C. So, A cross B intersection. So, A contains 1, 2, 3. Intersection of B and C is 4. So, 1, 4, then 2, 4, then the third element is 3, 4. So, these are the elements of A cross B intersection C. See here, first find out the common element in B and C. B contains 4 and C also contains 4. 4 is the common element. B intersection C is 4. Now, write down the cross product of A and this. A cross B intersection C. A contains 1, 2, 3. 1, 4, 2, 4 and 3, 4. Now, we will go for the second part. What is the second part? A cross B intersection A cross C. First, find out A cross B. The Cartesian product of A and B, these two. 1, 3, then 1, 4. Similarly, 2, 3 and 2, 4. 3, 3 and 3, 4. So the Cartesian product of A and B is A cross B. Similarly, find out the Cartesian product of A cross C, A and C, this and this. 1, 4, then 1, 5, 1, 6. Similarly, take second element 2, 4, 2, 5, 2, 6 and 3, 4, 3, 4, then 3, 5 and 3, 6. Now, the intersection A cross B intersection. Now, therefore, A cross B intersection A cross C. The intersection of these two, A cross B intersection A cross C. So, in this we have 1, 3. Here 1, 3 is not there. 1, 4, 1, 4. We can write the common 1, 4. Then 2, 3. 2, 3 is not there. We have 2, 4 and 2, 4. 2, 4. 3, 3 is not here. 3, 4. Yes, we have 3, 4. 3, 4 common elements. That's all. So, 1, 3 is not in this set. 1, 4 is there. We have taken 1, 4. Then 2, 3 is not here. 2 and 3. We have 2, 4. 2, 4 is here. 3, 3 is not there. 3, 4. Where is 3, 4 is? So, therefore, this is the intersection. A cross B intersection A cross C is equal to 1, 4, 2, 4 and 3, 4. That's it. Hope you followed. This is an important problem indeed. Okay. Now, let us come to the next example. Let us come to this. A cross B union C. Now, third one. A cross B union C. This is A cross. Now, write down the elements of B and C. B union C. The union of this is 3, 4, 5, 6. So, what is A? That is nothing but A contains 1, 2, 3 cross 3, 4, 5, 6. Okay. The cross product of these two. 1, 3, 1, 4, 1, 5, 1, 6. Similarly, 2, 3, 2, 4, 2, 5, 2, 6. Again, 3, 3, 3, 4, 3, 5 and 3, 6. These are the values of A cross B union. Okay. Now, let us come to the second one. Now, first find out A cross B union A cross C. This is for the first answer. Now, come to the second problem. Fourth one, find out A cross B first. A cross B is equal to A and B. That is 1, 3, 1, 4. Again, 2, 3 and 2, 4. Again, 3, 3 and 3, 4. Okay, find out A cross C. A cross C. A cross C is equal to A and C. That is 1, 4, 1, 5, 1, 6. Again, 2, 4, 2, 5, 2, 6. Again, 3, 4, 3, 4, 3, 5, 3, 6. Okay, these are the elements of A cross B and A and C. See, A cross B, A and B, 1, 3, 1, 4, 2, 3, 2, 4, 3, 3, 3, 4. A cross C, A is 1, 2, 3, C is 4, 5, 6. 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, 2, 6, 3, 4, 3, Now the union of these two. The union. So now therefore A cross B union A cross C. The union of these two. That's it. So first write down 1, 3, 1, 4, 2, 3, 2, 4, 3, 3 and 3, 4. Then 1, 4 already here it is there. Then you can take 1, 5, then 1 comma 6, 1 comma 6, 2 comma 4 already we have written, write down 2 comma 5, then 2 comma 6, 3 comma 4, we have written already 3 comma 4, take 3 comma 5 and 3 comma 6. So these are the elements of A cross B union A cross C. That's it. See, avoid repeated elements. 1 comma 4, 2 comma 4, 3 comma 4 are repeated. Remaining elements are same. That's it. This is regarding A cross B union A cross C. Now let's come to the next problem. Now what is given here? Here this is, if A cross B is equal to P comma Q, P comma R, M comma Q, M comma R, find the elements of A and B. Here the Cartesian product is given. We have to find the elements of the set A and elements of the set B. Now we have to find set A and set B. Now what is the Cartesian product? This is given. As I told, if A cross B, what is A cross B? The Cartesian product of two sets A cross B is defined as x comma y, such that x belongs to A and y belongs to B. That means first member, all the first member is an element of set A and all the second members are the elements of set B. First member P, A contains P, again P repeated, M, then M is repeated. So here A contains P, first element P and the second element as M. A is equal to P and M. Next B, second elements Q, then R, Q and R. That's all. So these are the values of A and B. So A is nothing but the first member, all the first member elements, first element or first members of the Cartesian product A cross B, and B is the set of all second members, second elements of the Cartesian product A cross B. So if you write A cross B for this, P comma Q and P comma R, M comma Q and M comma R, you will get the same answer. So therefore A is equal to P and M, B is equal to Q comma R. That's all. Very simple problem. Now let us come to the similar type problem. If A cross B is equal to A comma X, A comma Y, B comma X, B comma Y, find A and B. So as I told, equal to A is nothing but the first member A and B, and B is equal to the second members. What are the second members? X comma Y. That's it. These are the values of A and B. If you write the Cartesian product of this, A cross B is equal to A comma X, A comma Y, B comma X and B comma Y, you will get the same value. So therefore A is equal to A comma B and B is equal to X comma Y. Hope you followed. Important for 1 mark. Now let us come to the next one is the properties. Let us now few properties. Let's have few note on this Cartesian product. So two ordered pairs are equal if and only if their corresponding first element are equal and the second elements are also equal. So two Cartesian product, that is the ordered pairs are equal if and only if the corresponding first pair elements equal to the second elements are also equal, then only the Cartesian product of A and B are said to be equal. Okay. So if there are P elements in A and Q elements in B, there will be P into Q number of elements in A cross B. If there are P elements in a set A and Q elements in a set B, then A cross B will contain P into Q elements. That means if number of elements in the set A is P and the number of elements in the set B is Q, then the number of elements in A cross B is equal to P cross Q. For example, if number of elements in a set A is M and number of elements in the set B is N, then the number of elements in A cross B is always equal to M into N. Let us consider if, for example, number of elements in set A is 3, number of elements in set B is 4, then the number of elements in set A cross B is equal to 3 into 4, that's equal to 12 elements. This is very important concept. So if A contains N elements and B contains M elements, then the number of elements in A cross B is equal to N into M. In general, if number of elements in a set A is P and the number of elements in a set B is Q, then the number of elements in A cross B is equal to A cross B is equal to P into Q. The number of elements in A cross B is equal to P into Q. If A and B are any two non-empty sets, for any two non-empty set, then A cross B is also a non-empty set. This is also a non-empty set. Okay, for any two non-empty sets A and B, the Cartesian product A cross B is also a non-empty set. And if it is a finite set, then it is A cross B. N of A cross B is also equal to a finite set. Now, if A cross A is equal to A cross A is nothing but A, B, C, where A, B, C belongs to A here. So, for a set A, B, C such that A, B, C belongs to A, here A, B, C is called an ordered triplet. This is called an ordered triplet which represents the coordinates in 3D, x-axis, y-axis and z-axis. So, these are the properties on a ordered pairs. Let us come to an example. What is the problem here? Here, if P is equal to 1, 2, form the set P cross P, that is ordered triplet. Now, first find out P cross P, P into P, 1, 2 into 1, 2. So, this is equal to 1, 1, 1, again 1, 2, 2, 1 and 2, 2. Now, write down the ordered triplet P cross P is equal to, again with this 1, 1, 1, again 1, 1, 2, 1, 2, 1 and 1, 2, 2. Similarly, take the second element, that is 2, 1, 1, 2, 1, 2, again 2, 2, 1 and 2, 2, 2. These are the triplets, that is ordered triplets are A, P cross P. Now, let us consider one more example. If A is equal to minus 1, 1, then find the set A cross A, the triplet. So, here let us find out A cross A first. A into A is nothing but minus 1, minus 1, minus 1, 1. Again 1, minus 1 and 1, 1. Now, write down the triplet for this, again with these elements, that is A cross A. This is equal to minus 1 with these elements, minus 1, minus 1, minus 1, again minus 1, 1, again minus 1, 1, minus 1 and minus 1, 1, 1. Again the second element is 1, 1, minus 1, minus 1, again 1, minus 1, 1, again 1, 1 and minus 1, and the last element is 1, 1 and 1. So, these are called the triplets A cross A. That's it. Hope you follow this. Okay. Now, let us come to the next problem. Here, what is the problem given? If R is the set of all real numbers, what do the Cartesian products of R cross R and R cross R represent? So, here this first one, R cross R, the set of real numbers to real numbers, this is of the form x, y such that x belongs to R and y also belongs to R. So, that is nothing but this will represents, then ordered pair x, y will represents the coordinates in 2 dimension. These are the coordinates of a 2D. So, this x, y represents the coordinates in 2 dimensions, coordinates of all the points in 2 dimension space. Now, whereas second one, the second one is R cross R. This is nothing but, this is R into R will represents x, y, z such that x, y, z belongs to R. This will represent the set of all the coordinates in space in 3 dimension. The coordinates in space, coordinates of space in 3 dimension, 3-dimensional space. That's it. Okay, that's all. So, this will represent the all points, the coordinates of all points in 2D space whereas the coordinates of all points in 3D space. That's regarding two-dimensional coordinates, and three-dimensional coordinates in the space is represented by r cross r, r cross r cross r, triplet. So these are few problems based on the ordered pairs and the Cartesian product. Okay, now that's all regarding today's session. Let us meet with different concepts in the next class. Thank you very much.